Math Hoppers. In this video lesson, we are going to tackle solving rational equations. So let's review what a rational function is. It's kind of the ones we hate. They're in the form f of x equals g of x over h of x. So polynomial divided by polynomial. It's just one big fraction with x's everywhere or variables everywhere, which is kind of why we don't like them. Remember, if you have a polynomial in the denominator, that means you have variables in the denominator. So whatever is in the denominator, h of x, can't be equal to 0 because we can't divide by 0. So if we can't divide by 0, that means not every single value of x is going to be allowed for these functions, because a domain is all of the possible x values for a function, and these rational functions are going to have limitations on that domain. Not every x value is going to be allowed. Rational functions will be undefined wherever the denominator equals 0. So whatever value or values of x make the denominator 0 will be not allowed in the domain. They'll be excluded from the domain. So because so many of these functions have limitations on the domain, we have to check every solution we get for extraneous solutions. What's an extraneous solution? Extraneous solutions are solutions that you get by following the correct steps, but they're just invalid because they're outside of the domain for the function. So before we solve, we're going to identify the domain for these and keep it in the back of our head. So let's look at x plus 12 divided by x equals 7. So what makes these scary to solve is the fractions, or in this case, just the fraction, singular. But what we're going to do is get rid of the fractions by getting rid of the denominators. Once you get rid of denominators, you don't have fractions. So we're going to say, what is my lowest common denominator? What can I multiply every single term by to clear the fractions? Well, I only have one fraction, and if I want to get rid of it, it's x. So I multiply every single term by x. My lowest common denominator is x. Now let's think, what limitations on my domain do I have? Nothing here. Here I have an x in the denominator, so x can't be 0, because I can't have 0 in the denominator. So my domain is all real numbers except 0. Pretty easy. Now let's go ahead and do that first step. We are going to multiply every single term by x. Remember, when you make the decision to multiply in an equation, you multiply every term. So we have x times x plus x over 1 times 12 over x. You don't have to put x over 1. You'll notice anytime I multiply it by a fraction, I do, just to keep everything neat, equals 7 times x. Let's divide out our x's. X divides into x one time. And now let's multiply. X times x is x squared. Here we're just left with 12 times 1 over 1. So that's just 12. So x squared plus 12. Here we get 7 times x, so that's 7x. We should notice very quickly that we have an x squared term. As soon as you have an x squared, and it's the highest power, you have a quadratic. So what we have to do is solve this like we would solve quadratics. So what we're going to do is put it in standard form. Once you have a highest power of 2, think quadratic strategies. Quadratic functions really never go away. Once you learn them, they keep coming back again and again and again. So we're going to subtract 7x from both sides of this equation to put it in standard form. Remember, ax squared plus bx plus c equals 0. So x squared minus 7x plus 12 equals 0. Now we have a quadratic. We could just solve this like we've solved every other quadratic, but once we do, check for extraneous solutions. So let's give ourselves some more room. And let's see, how do we solve this? We need factors of positive 12 that add up to negative 7. So factors of a positive, same sign. They're going to add to negative 7. That sign's going to be negative. So factors of positive 12 that add up to negative 7, x minus 4, x minus 3. Or negative 4 and negative 3. Remember, these are just factors. We haven't solved anything. We've basically written it in factored form. Set each factor equal to 0 and solve for x. So we say x minus 4 equals 0, x minus 3 equals 0. Solving x minus 4 equals 0, add 4 to both sides, x equals 4. Solving x minus 3, add 3 to both sides, x equals 3. Now let's check them. Now I remember the only thing excluded from my domain was 0, so these should be good. But let's check them in case I messed up my domain. So 4 plus 12 divided by 4 equals 7. Well, 4 plus 3 does equal 7. Now 3 plus 12 divided by 3 equals 7. And 3 plus 4 does equal 7. So my answers are x equals 4 and x equals 3. Not bad. Let's try one that's a little more involved. So here we have x minus 3 over x plus 3 over x squared plus x equals negative 3 over x plus 1. You will see they do this a lot. If you look at my denominators, I have 3 different denominators, but 2 of the denominators multiply to give me the third. Well, that very clearly means that This third one is my lowest common denominator. I'm going to multiply everything by x times x plus 1, or x squared plus x. I keep it in factored form. It makes it much easier to divide out my denominators, but you could do it however you want. So the lowest common denominator is x times x plus 1, or x squared plus x. And let's look at my domain. I can't have 0 here. Here I'm okay, I'm squaring x, that's all right. Here, what would get 0 here? Well, really a -1 would get 0 here. And a 0 would get 0 here, right? X squared plus x if x were 0, but we've already eliminated 0 from here. So my domain is all real numbers except 0 or -1. Now we're going to multiply by my lowest common denominator. So we have x times x plus 1 times the first term, x minus 3 over x times x plus 1 times the second term, 3 over x squared plus x, equals x times x plus 1 multiplied by the last term, right? All right, so let's do this. Let's cross out or divide out everything that divides out. Here I'm going to divide out x and x because they'll divide out. X divided by x is 1. Here the whole thing divides out. X times x plus 1 is x squared plus x. Here my x plus 1 divides with x plus 1. So now I have to clean this up because it's kind of a mess. So I have x plus 1 times x minus 3 plus just a 1 up here times 3. So that's just going to be plus 3. That's pretty nice. Equals, the only thing left here is x times -3. So that'll be a -3x. Let's get that written. There's still a lot going on, but it's way better than what we started with. Okay, so remember we have two binomials we have to multiply, x plus 1 and x minus 3, which means we have to FOIL. So we do x times x times -3, 1 times x, and 1 times -3. We get, and then we're going to keep the 3, don't lose your 3. We're going to get x squared minus 2x minus 3 plus the 3 we haven't done anything with equals -3x. All right, so -3 plus 3, we could just cross that out. That's fine. We're going to get rid of that. That equals 0. But again, I have a quadratic, right? I have an x squared as my highest power, but it's not in standard form. So I'm going to put it in standard form by adding 3x to both sides and getting rid of my -3 plus 3, which just equals 0. Now I get x squared plus x equals 0. This one's not too bad to factor. The only thing I could take out of both terms is an x. So let's factor out or divide out an x. When you do that, x comes on the outside, you write parentheses, and x squared divided by x is x, so in the parentheses you put what's left after dividing. X divided by x is 1. So we have x times x plus 1 equals 0. Set both of those factors equal to 0 and solve for x. So we have x equals 0, don't have to solve there. But x plus 1 equals 0, we have to subtract 1 from both sides. We wind up getting x equals 0 or x equals -1. Now, I don't know about you, but I distinctly remember two values being excluded from the domain, and I think it was those two values. So let's check those for extraneous solutions. When we put in 0, something bad should happen, and it does. 0 minus 3 divided by 0. I'm not even going any further. Notice I didn't even put 0 in for all the other x's. Once I get 0 in my denominator, I know that's not okay. We are not allowed to divide by 0. N-O, remember the N over O, not okay to divide by 0? That makes 0 extraneous. Don't go any further. Let's check -1. -1 minus 3 divided by -1 plus 3 over -1 squared plus 1 equals -3 over -1 plus 1. Well, -1 plus 1 is 0. That's in a denominator. That means I am not allowed to divide by 0. That -3 over 0 is not okay. It makes -1 extraneous. So we could have realized that, hey, 0 and -1 are excluded from the domain, so clearly these are extraneous solutions. But just in case we didn't calculate the domain correctly or you forgot to calculate the domain, go ahead and check your solutions. In this case, this function literally has no solutions. All right, so not every rational equation looks the same. Let's go over the steps you're going to use. First thing you're going to do is identify the lowest common denominator that you can multiply every term by, and identify the domain, because that's going to come in handy with your extraneous solutions. You want to multiply every single term by the LCD to get rid of all the denominators, which in turn gets rid of all the fractions. Then you solve for x. You're probably going to get a quadratic. They come up a lot in these. So remember your quadratic strategies when you're solving these. And last but not least, substitute all solutions back and check for extraneous solutions. You will get them more often than you think. All right, still have questions? You should be subscribed to our YouTube channel. That exists for you to send any problems you need help with into us, and we'll make you a custom video solution. Until next time, Math Hoppers, take it easy.